Hello dear friends, we will verify the parallelogram law of forces and triangle law of forces experimentally. You know very well what is the parallelogram law of vector addition. If P vector is represented by a line of the parallelogram OE in magnitude and direction, and Q vector is represented by the another line of the parallelogram like OB in magnitude and direction, then the diagonal of the parallelogram, that diagonal which is passing through the intersection point, that diagonal which is passing through the intersection point, means this diagonal will be the sum of two vectors, P vector and Q vector. Okay, like that, if the two vectors are represented like A vector and B vector along the two sides of the triangle, taken along the same order, right? Taken along the same order, then the third side of the triangle will represent the resultant by taken along the opposite order. A vector and B vector are along the same order. The third side will be the resultant of the two by taken along opposite order. Mean like this. Okay, we'll verify parallelogram law experimentally. Now here you notice that we are having a hanger. This is a hanger. Okay, this hanger itself having a weight equals to 50 gram, and we can put another weight of 50 gram, each of 50 gram, right? We can put the another weight 50 gram, again adding more 50 gram weight, and go on. So, you know, like we're having the three hangers, 1, 2, 3. Three hanger with the weights, which the weights can be adjusted. Well, we can adjust the weight according to our choice by adding 50 gram each. Now what we are doing, like just see here, we are having a thread, long thread, and at the ends of the thread we tie the weights, hanger weights. Okay, so this is a long thread, and at the ends we tie the two hanger weights. Now remember, if this is the middle point of the thread, then from the middle point we attach another thread. Okay, and then we tie the thread at here. So a knot will be formed here, and we attach another hanger and weights at the middle of this thread. Okay, so this is how we assemble. Now looking here, now this is a drawing board or which a paper is, there's a paper is pasted, and the other two pulleys perfectly frictionless. Now, so we are having the three weights with the threads passing over the pulleys. We call this weight as P, another as Q, and this one as R. So we take a glass strip. This is actually a meter scale, but don't use it in the experiment. So this is a precaution, or it is my advice. Use the mirror strip, long mirror strip, just to point the thread, just to mark the thread positions at here and at here. To mark the thread position, use the glass strip. So because the thread will be visible in the glass, and then it will be easy to mark the points below the thread over the paper, right? And there will be no parallax in that case. So use the mirror strip instead of the meter scale. So just marking the thread points, right? Marking the thread points as well as the note. So this is the position of the, this is the position of the note, and we marked the thread points for this thread, for this thread, for this thread, as well as the note point, with the help of, with the help of the mirror strip and a pencil or pen. So note down the weights, like this is a weight P, this is a weight Q, and this weight is unknown weight. We don't know this value. Okay, we assume that we don't know. Otherwise, it is known to us. And you can have unknown weight actually here. Okay. So this P is, here it is. Now we'll complete the parallelogram. How? Because along this side, the weight was 200 gram. 200 gram. Then I have chosen a scale such that 50 gram is equivalent to 1 centimeter long. Okay, so if there is 200 gram, that becomes 4 centimeter. So this length is 4 centimeter. So I cut it 4 centimeter. I cut this length 4 centimeters. True. Now along this side, the weight was 250 gram. The weight was 250 gram. Okay, now because 50 gram is 1 centimeter, 250 gram means 5 centimeter. So I cut this length equals to 5 centimeter. Okay. So I cut this length as 5 centimeters. Now this is also, 5 centimeter. I completed the parallelogram. And this is also equals to 4 centimeter long. This is also 4 centimeter long. Now Now measuring this length, the length of the resultant vector. Now this becomes the resultant from here to here, and this resultant will give us the unknown weight, the value of the unknown weight. It seems that it is 6 centimeter long, but this is not correct, because recording by camera introduces some parallax. So this is not exactly 6. It is somewhat the higher value, higher than 6. Okay, it is somewhat higher than, more than 6. So it seems like 6, but it's not actually 6. It's maybe 6 point, it seems 6.1, but actually it is 6.2 centimeter. Okay. So it's not actually 6.1, but 6.2. So we make a correction for this value. So this is 6.2. Right? Now, a question for you. 6.2 centimeter represents to how much weight? Because as 1 centimeter represents to 50 gram. And what about the 6.2 centimeter? Find it. Very simple mathematics. Okay, so this was 200 gram. That's why we cut 4 centimeter. This is 250 gram. That's why we cut 5 centimeter. So unknown weight is 300 gram. We know it is 300, but in question it is unknown. Okay, now we find what is the length of the resultant, and we find the angle, or the angle between P vector and Q vector. That angle between 200 gram and 250 gram. So this angle is approximately 90 degree. Right? It is somewhat 90. So that becomes easy if the angle is 90, because you know the formula. R vector is under root of P square plus Q square plus 2PQ cos 90. Cos 90 is 0. So R is under root of P square plus Q square. Now substituting the values P and Q. And meanwhile, you measure the length. You measure this length. This is equals to, because 6.2 centimeter, then how much it will give us it gives us the weight. 1 centimeter gives 50 gram. 6.2 centimeter gives how much? 50 into 6.2. That becomes, just multiply it. So it becomes, I think, 310 gram. So this is 310 gram. But actual weight was 300 gram. So there is small error. Error because when we did the experiment, we used the meter scale for measuring, for marking the thread positions. We should use the meter scale, but we should use the mirror strip. So what is the error? Error is 10 gram. For 300 gram, the error is 10. And what is the percentage error? You just find that. So this is error which is coming because the position we mark, the thread positions with the help of the meter scale, we should be with the help of the mirror. Okay, so that's why there is smaller error, which is about 3%. So the result will be more accurate if you keep in mind the precautions and exact procedure. Okay.